Hi. This next lesson that we're going to get into deals with mixtures. Mixtures as defined forms when two or more substances are combined such that each substance retains its own chemical identity. Now, a lot of gobbledygook there, but basically what we're saying is we're mixing two things together, they don't react. They're just there. Now, there's some examples here. First example would be seawater. That's not seawater, that's sheep and goats. So we'll come back to the seawater in just a little bit. Here's sheep and goats. This is an example of a mixture. As you can see, the sheep and goats are living rather well with each other, but that's a mixture because we can see the different parts of it. Another example of seawater, which I hope I can get right this time. So let's see seawater here. Seawater is, I believe, that one. There's seawater right here. This seawater right here has got a nice big turtle in it. It's got little floaters in here. I'm not sure what that is. It might be algae, might be leaves. It's got some other things out here. Might be a little fish. Got a rock there. Got a mixture of a lot of things in here. What you don't, and that's just things you see. What things you don't see is that seawater contains a lot of salt. Sodium chloride is a salt. It is not the salt. There's all kinds. There's thousands of salts. Sodium chloride, which is the salt that you know, is called table salt, and that is certainly in there. But there's also magnesium sulfate, calcium chloride, all kinds of salts in there that are floating around and dissolved, so you can't see that. We also have air in a house. If you look around, you can't see the air in the house, but you know it's there. How do you know? Because you're alive. But it isn't just oxygen. In fact, the most abundant gas in the atmosphere is nitrogen. And so we call that the solvent. It's the stuff that's dissolving everything else. You got oxygen, you got argon. Argon's number 3, it's a volatile gas. If you've looked at your periodic charts, you've seen that on the last column there. Carbon dioxide, which has been in the news a lot recently. Methane as well has been. And what we call free aerated rear types. Another one is the saline solution. And the saline solution, for those who have contacts, are probably pretty familiar with saline solution, but saline means salt. And a saline solution is sodium chloride dissolved in water with a little extra something added to kill bacteria. But that is a mixture, and again, you can't see all the particles. In fact, you can't see any particles. You see the water that is dissolved in sodium chloride and has dissolved whatever they use to kill the bacteria. Okay? So that's what we have here. Those are 4 examples. And most of the materials on Earth are either compounds or mixtures. It's not that common to see pure elements. Okay? These are all mixtures because all the substances are mixed together, but none of them lost their identities because they are not reacting with each other to create a new substance. So that's what mixtures are all about. However, 2 distinct differences can be made in these mixtures. Being able to see the different parts of each mixture, like we saw with the goats and the sheep, or we saw with the seawater with the creatures in it, or not be able to see them, and that the particles are either evenly distributed or not. Those are the 2 areas that distinguish themselves, how we can tell if what type of mixture we are dealing with, and that's what we're going to get into now. In the case of seawater, one can see much, but not all, of the components that make up the mixture. Like I said, the animals, the rocks, the sea creatures, all that stuff you can see. But the salts we can't see. Same is true with the pasture land animals, the goats and the sheep that are mixed together. However, one cannot see the different aspects of the air in a house or of the saline solution. We know it's a mixture because if you're to actually drink the saline solution, you know right away that you're not drinking just water. You're drinking water and salt, and you might be able to taste whatever stuff they put in. I can't imagine that good for you, but if you did, you may not notice exactly what that is. It might be a little aftertaste that's not so good. Because of that, they were given names. Heterogeneous and homogeneous. Those are the two terms we use to describe these types of mixtures. Okay? So, the prefixes hetero and homo come from the Greek words that mean different for hetero and similar for homo. And with your biology training that you had before you came to me, you use those prefixes before with heterozygotes and homozygotes, I imagine, which have the same meaning, but they are dealing with different or similar types of genes. So heterogeneous and homogeneous mixtures are what we're looking for. So, your practice problems on this that I'll be discussing with you when you are ready to take your quiz, or any questions you may have, feel free to talk to me about it. But I want you to think about these 5 mixtures. These are all mixtures here, okay? And I want you to tell me if those mixtures are homogeneous and heterogeneous, okay? So that's all you have to do with that. Have fun with that.